Alright, please do not skip this video for the sake of your own happiness on your journey to becoming a master of Zephyr OS. In this video, I'm going to talk about a concept that is key to the portability of firmwares that are built using Zephyr OS, and this concept is known as the device tree. If you paid attention in the previous videos, which I believe you did, I'm sure you saw certain things in the code base that were quite alien to you. For example, DT alias led 0, GPIO DT spec get, and there's also GPIO here. Now, what makes it even more mind-boggling is that these aren't regular C variables or even macros that we have defined in the code. So then the question is, where are these coming from and what is it, right? Now, Zephyr is backed by the Linux Foundation, and so it borrows a lot of techniques from how things are done in the Linux operating systems. And one key aspect that it borrows is what is known as the device tree. Of course, it borrows other things like kconfig, but we are going to talk about those when it becomes necessary. I want you to pay attention to something here that I have highlighted. This one. You see that when you are building your application and you check the logs, there are a lot of information in there that actually helps you to understand what Zephyr is doing behind the scenes. For example, it says found board.dts, and then it shows you the path to where that particular DTS is. Now the question is, what is a DTS? A DTS is a device tree source. So then the question is, what is a device tree? You know, usually in hardware programming or firmware design, we describe hardware to the software using some header files, right? So if you're coming from the STM world, you expect to have some header files from a package like the Simpsons core, where you include, let's say, STM32F4 07 underscore xx.h. And in this header file, we have the definition of all the registers and peripherals and the pins and even values that you can set to particular places in these registers to get things done, right? So that's the primary way we know how the firmware we are writing actually gets to interface with the hardware. Now, because Zephyr OS wants to deliver portability, it chose a different approach, which is the device tree source. So in the compilation output here, you can see that it says it got some device tree source file from this particular path here. And so if you go to your workspace, let's say this is STM32, you go to debs, you go to Zephyr, you know, there are definitions here. There are board definitions here, and they are categorized by vendors. So I am using ST, so I scroll all the way down to ST here. And there are various device tree source definitions for various boards. Now let's go and understand what a device tree source is. So a device tree source is basically a tree-like hierarchical data structure that is used to describe hardware to your firmware. And this description can be at the SOC level. So like there are device tree source files for the system on chip. You know, in the videos you have seen me using development kit. These are boards that have the SOC on them. It has the system on chip on them. And so basically these boards are adding things like LEDs and other sensors and stuff to make the SOC be able to do certain stuff that the board wants to offer. So the definition of these device source trees are actually also hierarchical, and you can include them, which we are going to see very soon. I'm trying my best not to make it confusing, but to also not make it so long and unnecessarily detailed until we need that. So we see here that where I selected, we saw that it said it's using some Devicetree source, which is called STM32F4 Disco DTS. So let's go in there. Let's see what a Devicetree source is. So this is what a Devicetree source looks like. It kind of looks like JSON, but it's not really JSON. It also looks a bit like C, but it's actually not C, right? So it borrows syntax and semantics from both JSON and C. Now, ignore what is up here for the time being, and let me explain what's going on down here. A Devicetree source is made up of what is known as nodes, right? And so this here, the chosen, is a node. LEDs is a node. And nodes can be children to other nodes, and a node can be a parent to other child nodes or children nodes. And inside these nodes, we have what is known as properties. And properties are just key value pairs. So to make it even more concrete, let's take the LEDs or LEDs node. This LEDs node is a child of the root node, which describes this board right here, STM32F4 Discovery. And inside the LEDs node, we have a property called compatible, and so it just key value pairs. And then we also have another node here, which is known as LED3. Now, nodes can also have what is known as labels. So if anything precedes the name of a node with a colon after it, then it becomes a label to that node. So the node here is actually LED3, but a label for this node is orange LED3. And there are ways by which a node can reference other nodes as well. So this is how the hardware is being described to the firmware that we are creating. And it's the job of the build tool to read these Devicetree source files, and in the process of building the firmware, generate a header file that is included in our code. So these things are not really transparent to us. We don't see it happening because we don't do them manually. But it's the job of the Zephyr build system to actually look at the board you've chosen, take the correct Devicetree source, and be able to come up with that header file that will be included in your project, which helps you to access hardware peripherals on the particular board that you are creating the firmware for. So if we come here, you see that we said define LED node is equal to DT alias LED 0. Now, here's the connection between the C code and Devicetree as a technique for ensuring portability of firmware. If I come here and I look for LED 0, I find it down here, and it is defined in a node called aliases. And in here, I can see that LED 0 is pointing to green LED 4, right? So if I search for green LED 4, I'll see, what was this? Let me copy this and paste it here. Let's go up. So I can see that, okay, this is green LED 4. And it is connected on GPIO pin 12, right? So if you have read the data sheet for the particular board you are using, it will also help you to understand how the Devicetree maps to the register definitions in the data sheet of your particular board or SOC that you are using. So back to how we are able to reference these definitions in code so that we're able to do things with the peripherals. If you come here, there is a provision of this macro called DT alias. So DT alias stands for Devicetree alias, and it helps us to be able to reference a particular node using alias. That is how come if I come to Devicetree and I search for LED0, I can see that LED0 belongs to the aliases node, and it is referencing, look at this ampersand here. This is something they borrow from C, but this is not actually C. So it is referencing green LED4, right? So what it means is that on my board, if I change the code to, let's say, LED3, some blue LED must be blinking. Let's go do that before we come back here to come and continue our journey. So I've changed this to LED3, and I'm going to compile this code. It's done compiling, and I'm going to flash it onto the board. And the flashing is done. So I'm going to switch to a place where you can see me. And over here, you can see that indeed there is a blue LED that is blinking on the board. So I'm going to go back to my explanation for on device trees. Yes, so this is what I want you to take from this video, that because Zephyr wants to be portable, it has chosen this technique of device trees to help describe hardware to your firmware, so that whenever we change the board type, as we did in previous videos where I changed from STM-F4 to STM-F3, and then I even changed to a Nordic semiconductor board, it worked because behind the scenes, it changes the device tree source that it is using as part of the build system to describe the hardware to your firmware, right? So I know this sounds a bit vague, but in the next video, I'm going to go a bit deeper to help your understanding. But I also like to mention that you don't have to worry so much about it at this phase. Just have the understanding that there is a technique that is gluing your firmware to the hardware. And in this course, in subsequent videos, as it becomes necessary, we will learn how to actually define or modify device tree source or override certain definitions in there to get our firmware to do what we want it to do. So thank you very much for watching, and I will see you in the next video.